So I wanted to just kind of introduce Dave here, the genius behind Take 5 and tactical flow meters. And Dave, why don't you just talk about your background with Sierra Instruments and why you decided to create your own flow meter company?
Yeah, well, I started with Sierra when Sierra was in Carmel Valley with John Olin and Jerry Kurz, and that's about it, a couple other guys. And I learned how to sweep floors, learned how to write checks, I learned how to solder, learned how to, had a great level of interest in all of those things, and worked my way up, if you will. And at the time I was going to University of California in Berkeley and studying mechanical engineering. I said, whoa, I'm missing the boat here. I don't have the electronics that Jerry Kurz was telling me to do. And I learned most of my electronics from Jerry in a practical way, making linearizers and bridges and controllers and such for air samplers for the pollution industry.
And Jerry Kurz is one of the founders of Sierra Instruments.
Yeah, John Olin and Jerry Kurz both did it. And worked long enough, those two guys got in loggerheads. My brother was a shrink, and he met with them, and in the end they met and said, we got to split up. So Jerry took his part, John took his part. John and Jerry both said they won't compete in each other's play field for a period of time. Jerry was flow meters, John was everything pollution. And then when that time went away, John called me up and said, we're making a flow meter, let's do it. And I said, man, I've been biting at the bit to do that. So we made
It's just to back up, you were kind of the person designing a lot of the flow meters, so you wanted to go get back into that.
Yeah. So when I sold my part of Sierra, I retired and did nothing for 5 or 10 years. And I said, wait, what's happening? No new technologies coming. Not a whole lot of advancing in the field. So I said, well, I'll start doing my own thing.
You basically couldn't stop tinkering. You're looking at these flow meters and you're like, we got to make these better. Thinking about LabVIEW, saying I can do a better job. So let's get on this.
Yeah, that's what I did, and then I started working with a lot of folks in China because I had a patent course that I helped folks get patents, and in that I met a lot of machine shops and fabricators in China where I'd get one of my customers was making some belt for holding a tool and having this thing made in China. And so I have all kinds of vendors, injection molding, machining, 5-axis machining, sheet metal, injection molding, whatever. And then I went to China a few times and met folks who were making flow meters, and they were okay with me saying, I want to make it my way. And so I designed it here, made it in China, ship it here, and then we calibrate them and put them together and we make every type of flow meter: vortex meter, mag meter, turbine meter, Coriolis meter, time of flight meter, a clamp on ultrasonic, and all of these technologies have taught me that what I learned how to do things at Sierra was a bit short-sighted, and so I learned from the big boys, folks who make Coriolis meters and know what they're doing. Mm-hmm. Listen to them. And we were at Sierra and we were always laughing at these silly vibrating machines and why would they make such a thing when it's so much easier. I should show you this stuff here. This is a primary standard calibration system. It's called the CalBench. It's not sold by Sierra anymore, but Dave Rodriguez here sells and maintains these, and actually keeps them up to date at Sierra. They probably got how many of them?
16 and 20 belt movers.
16. We've got 16 of these things.
And this is something that Dave invented.
Yeah, I have a few patents.
He's got a few patents on it.
And a few patents on this.
Another thing he did in his spare time, he's like, I'm going to make this thing. He's explained it to me a couple times.
This thing was made because nobody had a way to characterize these things. So I made a method of doing it and automating that method.
And basically, when we say characterize, we mean mapping a lookup table, if you will, of an output that corresponds to a flow rate.
Yeah, that's right.
And we need to characterize it so that we can create that lookup table properly. And in order to do that, we need really, really accurate measurements. And this thing right here gives us those very, very accurate measurements. Is that sort
That's
of a
right. This has an uncertainty of 0.2%.
That's correct, 0.2%.
0.2% uncertainty. See, we have this accuracy uncertainty in America. We say, oh, I want a 1% accurate meter. Oh, so no sweat, I can make that. 99% inaccurate? How easy is that? So what they really should say, I want a meter with an uncertainty of 1%. This has an uncertainty of 1%. Then they call it a 1% accurate, which is 99% inaccurate. So anyway, we characterize in any flow meter, this kind of flow meter, and many companies make flow meters. Very few use things like this. They don't use this because what they'll do is they'll take this, well, I calibrated this one at Frank's house, and I'll put this one together, and Frank says this, and yours says that, and, and this is my standard. And fundamentally, it is so wrong to calibrate something that operates in the same way with another thing, because that which affects this affects that. So you have to operate different, there's whole theories about it, but it kind of makes sense. If the whole,
I think garbage in, garbage out is maybe
yeah,
you're calibrating it against something that's not accurate.
well, you think it's accurate, but maybe it has sensitivity to photons, who knows, some silly thing,
Yeah.
or sensitivity to sunspot activity that will affect both of them equally, so they'll both have a deviation equally, but they match each other. But this guy doesn't care about sunspot activity or whatever.
So we got the right gold standard that we're
Yeah.
characterizing it to,
Yeah,
but
this is considered a primary standard because it's derived from length, time, and mass. Mass is the pressure transducer. It's so many pounds per square inch, and length is fundamental, and time comes from a crystal thing. This has the innards has a 50 megahertz time crystal that's like crazy accurate.
so let's talk a little bit more about what this does and how we use that to calibrate things. What does this measure here? This device that
This
we're looking
thing
at.
measures the volume of fluid being given to it, volume of gas being given to it, that we then correct to, they call them standard liters per minute, should be grams per minute. Standard liters per minute means liters per minute corrected to some STP, which is Spanish for we're telling you what the density is.
Okay,
So
fair
they
enough.
should be really just using grams per minute, but
Because that makes more sense, because that's what's coming in is a certain number of grams of gas.
Yeah,
Okay.
that's mass.
So basically what we've done there is we've measured the amount of gas, and we know how long it's taken to add that gas to the system, so we're getting a flow rate.
Yeah.
Is that right?
That's right.
Cool. And then we have the actual flow rate from this system here, and then we have the flow rate that we think we have, or measured by the device.
Yeah.
We figure out the it's not error, but what output from
Characterize it,
yeah,
if you
what output corresponds to what flow rate.
Yeah.
Get all that data, and then we run through the lab view, and voila, we have an accurate system.
That's right.
And this is really a big chunk of the secret sauce.
This is unobtainium for many folks. In fact, they don't even know that they need this thing. That's how bad it is.
So if there's some other company out there trying to design flow meters, they don't even know this exists, what we're looking at right now.
They know, but they don't know. In my experience working in this field, I'm appalled at how little is known about what it is the folks are making. And the other thing, in all that disarray, it still works.
The bar's set kind
People
of low.
really don't need to know as accurate as they think they do. Just because their paper said they need a 1% thing. The fact is probably the reason most of the stuff still works is that it doesn't matter that much.
You can be off by 2%,
Yeah.
3%.
Yeah.
Nobody's gonna
Who
know.
says 1% is, I don't know, 1%? Did they actually work it out and work out the chemistry of all making peanut butter or whatever they're doing with it? Or these things, these are the magic that inject the gases into the cylinders that are made. You know, the tools are made. Semiconductors are made with these things. These things, phosgene, silane, methane, whatever. Very, 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 very pure gases. So they're.
Let me ask you, I mean, one more thing about this is about you don't know what you don't know. Like, if you buy a flow meter and it's not calibrated by this, you're not going to know that it wasn't calibrated right.
Yeah.
And you're going to put it into the oil field and it's going to be off by 2%. Nobody's going to know.
Well, there's where George should show our calibration document. Nobody puts a calibration document together better
Like
than
George.
the way George did it.
All right, that's going to be.
You know what? It sounds silly. Most people, they don't even know they don't know. It's really, really important to report how you did what it is you did on the thing you did it on. So and George made a document format that is beyond awesome, following all the ISO 8178, all that.
And essentially what's going to happen is I'm going to buy a flow meter. It's not going to be calibrated by a gold standard. It's going to be calibrated by Joe's flow meter. So we're going to be off right away. We're not going to calibrate it correctly in the field. And then we're going to be off by 3% in our oil field. Nobody's going to know, potentially.
And you know,
So you get away with it
that's
because
assuming, you know, there are folks who don't do it well, and there are folks who
Yeah.
do it well. So there are both classes. The reason a lot of people are afraid of buying flow meters from unknowns is they don't know. They don't know what they're going to get. That's why there's names like Emerson and ENH that they must be doing it right. That's the theory. Yeah, they must be doing it right.
got it. We bought some software for $60,000 a year, and we decided to go with them because they're a big company. They're owned by IBM, so it has to be right. But that's not always the case.
That's right.
Yeah. Cool.